Good afternoon, everyone. I hope you are having a great VMworld. My name is Naveen Nagaraj. I manage the distributed resource management and the high availability R&D team at VMworld. My team is responsible for DRS, storage DRS, SIOC, DPM, and vSphere HA. In today's presentation, I will be going over some of the advanced concepts of DRS, and I will be trying to get into some of the specifics of how DRS works. Why is it important to get to know the specifics of DRS, how it works? I'll get into that one as I speak. The main reason why DRS is very important for you to know is it allows you to get the best out of your virtual infrastructure. So in today's agenda, I'll be giving some advanced concepts as to how DRS will make its decision. And then I'll touch upon some of the 6.0 features that were introduced. Then I'll talk about some of the best known best practices, essentially that will help you to make sure that you don't fall into some of the well-known pitfalls. And then I'll give a quick preview into the future directions of DRS. These are the features which will be included as part of the forthcoming vSphere releases. And last but not the least, I will open up the floor for Q&A session. Did you know that DRS is the #1 infrastructure scheduler in the data center? To that end, I will be sharing you some numbers that we have collected through telemetry, phone home, survey, and our customer engagements. 92% of the clusters have DRS enabled in them. There is only one feature which has more adoption than DRS. Anybody guess over here which is that feature? HA. HA has an adoption rate of 99%, while DRS is at 92%. 79% of the DRS clusters are in fully automated mode. As you know, DRS supports 3 modes: manual mode, semi-automatic mode, and the fully automated mode. By far, the fully automated mode is the most popular setting of DRS clusters. 87% of the clusters have affinity and anti-affinity defined in them. Affinity and anti-affinity are a great way to achieve some of the business rules that you have to specify, either because you have the licensing requirements or the availability requirements. I'll be touching upon some of those concepts when I talk about the advanced concepts. %43 of the clusters that are deployed have resource pools in them. Resource pool is a great way to achieve the segregation of resources in your cluster and to provide resource isolation. I have talked about most of the DRS features over here, but one feature is missing over here, which is the most popular. Any guess over here which is that most popular feature of DRS is? No takers? It's the maintenance mode. And any guess what percentage of the users use maintenance mode in their clusters? No takers again? 99.8%. So we're still not sure why it's not 100%. Either because our telemetry data is not properly collected, or there are some standalone hosts where in those standalone hosts you can't put it into maintenance mode because there is no other host where you can evacuate the VMs. I think it's the latter because it undermines my earlier numbers if our telemetry data collection is wrong. So now that we have seen this eye-popping numbers of how popular the DRS is and then how it has been embraced by our VI admins, let's look into some of the advanced concepts of the DRS. Knowing the advanced concepts of the DRS will help you to reason about why your cluster is behaving the way it is in your workload. No two data centers in the world are identical, and likewise what we have noticed is no two clusters are identical. There will be some nitty-gritty variation between the two clusters, even if it is managed by the same VI admin, same VC, same set of hosts that are being used. So I'll go into some of the advanced metrics that DRS looks into, so that will help you to understand why DRS is making some decisions. I will talk about some of the constraints that influence the DRS load balancing. And then finally, I will talk about the cost-benefit analysis. The cost-benefit analysis is a very important concept, because when you see your clusters not being balanced, then there is a reason to it. DRS is doing a cost-benefit analysis to understand whether a move should be made or it should not be made. So knowing the cost-benefit analysis in detail will help you to reason about why your cluster looks the way it looks. So let's dig into it. So DRS collects these host level and VM level metrics every minute. Every 20 seconds we sample the host statistics as well as the VM level statistics. There are hundreds and 200s of metrics that we look at for both initial placement as well as for load balancing. Here I'm not going to touch upon each and every metric that is collected and being monitored. I will just touch upon some of the key metrics that DRS looks into. The first and the foremost is the host level metrics. At the host level, we have the CPU that is being reserved for various reasons, memory that is being reserved for various reasons. This is not the reservation that you have specified on the VM. So let me make it very clear over there. These are not the reservation that you have specified on your VM. You have your VMX running over there, your VM kernel running over there, your agent VMs running over there, your FDM agent because of HA is running over there. All these agent VMs require memory reserved on the host, because these agent VMs are critical for you, the operations of your cluster. So there is memory reserved for your host, for as well as the CPU that is reserved for your agent VMs and critical workloads. So we take that into account during our initial placement and load balancing. Next, we look at the VM level metrics. Again, I'm not going to list out all the VM level metrics that we look at. I have listed out the ones which are very important over here. In terms of CPU, the most important one that we look at is the active memory. How much is being consumed by this VM? What kind of demand it has, whether it is getting its entitlement or not. In case of memory, the most important thing that we look at is the active memory and the consumed memory. When I talk about the advanced concepts, I will talk about what an active memory means, what an advanced memory means, or what the consumed memory means. And the most important thing that we also assess is whenever there are multiple VMs on a host, there will be page sharing that will be happening. So whenever DRS makes a decision, it knows about how much page is being shared between the respective VMs on that particular host. So if we move that particular VM from that particular host to a destination host, then we will lose the page sharing. So we will consider that as part of our load balancing calls. And also whenever we have to move the VM from one host to another host, you have to reclaim some memory at the destination host to make room for the incoming VM. So there will be some either the swapping or the ballooning that will be happening at the destination. DRS considers those as well as part of its initial placement and load balancing. Now I touched upon some of the important metrics over here, but at the end of the day, there is one super important metric that DRS looks into. And it's neither of the metrics that are listed over here. Any takers over here what that metric is? Nope. It's the VM happiness. So that's the most important metric that DRS looks into. All these metrics do influence the DRS initial placement and load balancing, but the trump card is the VM happiness. What do I mean by VM happiness? So what I mean by VM happiness is, if the VM demand is being met all the time in terms of both CPU and memory, then we consider that VM to be happy. It is requesting for some CPU cycles, we are able to give the CPU cycles for it. It's requesting for some memory, we are able to give the memory for it. Then we consider that particular VM to be happy. If a VM is happy, then we don't see a reason to move it around, even if we see that there is a slight imbalance in the cluster. Because at the end of the day, as I mentioned, the VM happiness trumps all other metric, including the cluster load balance. So the VM happiness is considered both during initial placement as well as the load balancing. In the initial placement, we will assess whether placing this particular VM will have any negative impact for already running VMs. It's not only about trying to power on the VM and finding a good place for it to power on. It's more important for us to ensure that the already running VMs are impacted at the minimal or even zero impact on the running VMs. That's the most important criteria for DRS when we power on a VM. Next, when it comes to load balancing, we follow the same principle there as well. When we move this particular VM from a source to the destination, we have to ensure that the VMs already running on the destination are not impacted at all. So now that we looked into the metrics, let's look into the constraints. As I said, no two clusters in this world are identical. It is because of the workload and because of the constraints. The constraints play a big role in how DRS does the initial placement and load balancing. There are two types of constraints. One is the explicit constraints which you would have specified, and you can see it in your UI or through Power CLIs. You know it because you set those constraints. But there are some implicit constraints as well, and I will touch upon both of them today. HA admission control policies. This is like one of the explicit constraint. You specify what kind of HA admission control policy you want. You would have specified either a slot-based or a unreserved capacity. That particular constraints will affect how DRS operates. We keep getting these questions again and again from customers where they ask, I change from one policy to another, what kind of impact does it have on DRS? Under the hoods, whenever HA does a failover after a ESX has failed, it consults DRS. Irrespective of whether you have enabled DRS or not, that algorithm is already integrated with the FDM agent. So even in your cluster, if DRS is not enabled for whatever reason, still DRS is in the action. Because when the host fails, we need to figure out like where to power on these VMs. And there is only one algorithm which makes that decision, and that happens to be DRS. Affinity and anti-affinity rules. Again, this is an explicit rule which you would have specified. Either because of the SQL Server license or an Oracle license, you would have asked certain VMs to run only on some host. That acts as a constraint. Whenever we do the placement, we honor that one. And these plays an important role even when we do the load balance. This is an implicit constraint. The number of vMotions that we trigger, we try to contain it to the minimal because vMotion isn't cheap. We always make sure that the number of vMotions on a per host basis, on a per vNIC basis, and the total number of vMotion per cluster is under certain limit. We assess what is the bandwidth that is available, how long is it going to take to complete the vMotions, and that influences our load balancing calls. So we also assess like what is the, it's a WhatIf analysis. It's not an accurate assessment as to like how quickly or how fast we can do the vMotion, but knowing the active pages that are being dirtied and also knowing where we are going to transfer this particular VM will give us a clear indication as to like how much time it is going to take for this vMotion to complete. We take that into account as part of our initial placement if there is a prerequisite mode required or as part of our load balancing. Data stroke connectivity. I'll cover this one in the best practices. In most of the clusters we see, we have like full connectivity. In certain scenarios where there is partial connectivity, either through PDL, permanent data loss, or like APD, there will be partial connectivity. the load balancing call will also take that into account. vCPU to PCPU ratio. There is a default value of vCPU to PCPU that we maintain. It's roughly around 8:1. And you can override this one. When I talk about the advanced settings, I will talk about like how you can influence this constraint. Of course, the RLS setting, this is again an explicit setting that you would have done either on the VM or on the resource pool. Agent VMs. These play an important role. As I mentioned, some of the agent VMs are vShield Edge, FDM, and then the other agent VMs that will be running over there with the dependencies. They have some kind of a constraint. We won't move a VM to a host where the agent VM doesn't exist, which it depends on. That will be an implicit constraint for us. And last but not the least, the special VMs. So I call them as special VMs because you would have enabled either the SMPFT on them, or you would have enabled vFlash on them, or you might have marked that particular VM as a latency sensitive VM. All of these act as an implicit constraint for DRS. Whenever these settings are there, either we will try to make sure that VM doesn't move that much, or whenever a secondary fails or a primary fails, we give special treatment for these VMs. So they act as like constraints for us. So now we touched upon the metrics that DRS looks into and also the constraints that influence its decision. Now we come to the most important part, the cost-benefit analysis and the minimum goodness. Like in life, whenever we make a decision, we assess the cost of making a decision versus the benefit we will be getting. Likewise, DRS also has the same notion. Whenever it has to make a decision, either for its placement or for load balancing, it first assesses the cost. And then it will assess what is the benefit I'm going to get by making this decision. If the cost is going to be higher than the benefit, then we reject that particular decision, meaning that we filter that out. Because there is no point in making that decision because I'm not going to get any benefit whatsoever. So let's look into like what constitutes the cost and what constitutes the benefit. The cost consideration is mainly in terms of like the impact of a vMotion. This is not that everybody understands. They think that vMotion is cheap and they think that we can move the vMotion over there. We give that impression, meaning that whenever you do the vMotion, we give an impression that there is no impact to the guest OS. To make sure that the guest OS has no impact, we incur the cost at the kernel level. And what is the cost that is incurred? On a 1 gig NIC, if you have configured your management NIC or the vMotion NIC for 1 gig, then we reserve 30% of the CPU on the source and the destination. And if it is a 10 gig NIC, then we reserve an entire core for the vMotion. Why do we do this one? If we don't do this reservation, then the vMotion will take longer because the active pages will be changing and dirtying, and we will be in the constant mode of catching up with those changes. So it's in the best interest that we reserve certain CPU cycles and memory for it so that the vMotion completes ASAP and your workload is not impacted. So that's the cost. The other cost which I already talked about is the memory reclamation. Because assume a host, a destination host where you are trying to move the VMs. If nobody is asking for any memory over there, and if some VM is like using all the memory that is available, we give that memory to them because there is no reason to hold back that memory. Anything they ask for, we would have given that particular, the VMs running on that one, and then they will be consuming all the memory. But now when you move the VM, another VM to this particular host, then you have to reclaim some memory. We will either use ballooning or swapping or one of the other techniques to like reclaim this memory to make room for this incoming VM. That also we consider it as a cost. Now let's look at the benefit consideration. In terms of like benefit, it's mostly around the performance. There has to be a positive performance both at the source as well as at the destination when we move the VM. What I mean by that one is, if a VM is moving from one source host to another host, all the VMs that are faring goodbye to this particular VM at least should have a positive impact because somebody is making room for them. So we assess that one. And when this particular VM goes to the destination host, the VM which has migrated over there should have a positive benefit again. So the positive benefit is for the leftover VMs at the source and for the VM that is moving over there. And also, as I mentioned earlier, the VMs running on the destination should not be negatively impacted. So those are the benefit considerations. And last but not the least, we will also look at what is going to be the cluster imbalance. If the cluster is going to be like imbalanced because of our move, then we will filter out that particular move. So once we do this analysis, we take the cost, we take the benefit, we divide it, and then we do some mathematical analysis of that one. After that, we spit out a number. That number ranges from -2 to +2. -2 being like pretty bad move to +2 being really good move. Now, once we assess the cost benefit, is it time to like trigger a move? Certainly not. There is something called as minimum goodness. Again, going back to my analogy of how we make decision in our life. If we are making a life-changing decision, changing a job or something like that, we do the cost-benefit analysis. After we do the cost-benefit analysis, we have a minimum bar. The benefit should be a little bit more than this one. If it is like few dollars here and there, you're not going to make a decision. You will have a minimum bar which it has to exceed, then only you make a decision. It has to be a positive benefit and it has to be like to cross a minimum bar. It's exactly similar in case of DRS2. There is a minimum bar which we call it as the min goodness. And how is this min goodness controlled? That is a slider bar which you set in your UI in terms of aggressiveness. If you set that bar to the middle, then the bar is like the min goodness translate to like 0. That means that if the value of our cost benefit analysis is either 0, 1 or 2, then they qualify for a move. If the value comes out to be -1, then it's below the min goodness and then we will not make the move. So what are the key takeaways from this deep dive? The initial placement is influenced by the ESX level metrics of both VM and the host. Constraints play a big role in how DRS does its decision. And last but not the least, cost-benefit analysis is done when we do the moves. But at the end of the day, VM happiness is the #1 influencer for both initial placement and load balancing. If you see a small imbalance in your DRS cluster, then it's not a major concern because, as I mentioned, all the VMs are happy wherever they are. There is no need for DRS to like unnecessarily trigger vMotion and cause cost in terms of like the network bandwidth or memory reclamation. The DRS aggressiveness of the middle setting in your DRS aggressiveness works the best. There is no need to like tweak around with it. I will get into the details of like when you need to tweak around with it in the advanced concepts or advanced settings. But most of the time, your default settings that we have tested with works best for most of the workload. So now we have a good understanding of the internal workings of the DRS. Let's jump into like some of the new features that were introduced in vSphere 6.0. In vSphere 6.0, we made some good headways into some of the areas. And knowing these features well will help you to like manage your clusters better. The first feature which we introduced is called as the network DRS, wherein DRS, which was mostly based on the CPU and memory, now also takes network into account as part of its initial placement and load balancing. You have the ability to specify reservation for your tier 1 applications. You can specify I want 1000 IOPS, or you can specify I want 5000 IOPS for this particular VM, and then we will maintain that reservation. So in the example over here, as part of the initial placement, as you can see, the host on the left has 3 NICs, while the host on the right has 2 NICs. When an initial placement is done, we will assess which of these hosts will be able to satisfy the reservation that you have mentioned, and then we will place the VM accordingly. Not only we do the initial placement, but we will also do the remediation. What I mean by remediation is, if that particular network bandwidth is not being satisfied, either because that PNIC is saturated, because all the VMs are pounding on the network and that PNIC is saturated, or if the PNIC fails. In both scenarios, DRS will remediate, meaning that it will move that particular VM from this host to another host where its reservation can be satisfied. And the move can be for the VM whose reservation is there, or we could like evacuate other VMs to make room for this important VM. So we have both choices. One thing to notice here is I didn't mention load balancing. I kept on saying remediation. That's an important distinction. DRS in the current version of 6.0 will not try to balance the network utilization uniformly across the cluster. As you know, the network utilization is like very, very choppy in nature, meaning that it's very bursty in nature. It's just like chasing a moving target. The network load keeps changing. Sometimes it's like heavy, sometimes the hotspots keep moving. So we did a lot of experimentation inside our company. We dog-fooded it, and then we realized that trying to load balance it for an equal distribution is like a lost cause. So we just introduced the remediation as part of this particular release. In the future releases, we will look into like how we can do the incorporate load balancing. And this will come up with integration with the NSX. I will touch upon that in the future direction slide. One of the marquee features of vSphere 6.0 is the ability to move the VMs from one VC to another VC. It has become quite common in many of the data centers to have multiple VCs. Gone are those days where one VC was managing the entire data centers. Now it's quite common that there are like more than a couple of vCenters to manage a data center. And the ability to move the VMs from one vCenter to another vCenter is very handy. Now, when you're moving this particular VM from one VC to another VC, there should be a placement logic that happens with it. And DRS does that placement logic. So as part of the cross VC vMotion, which we call it as xvMotion because it's storage vMotion plus your compute vMotion, we call it as xvMotion. As part of the xvMotion, DRS does the recommendation for both data store and host. Internally, when you do trigger the cross VC vMotion, both DRS algorithm as well as the storage DRS algorithm are run in parallel. And then we make the best choice for both of them. So you get a tuple for both a host as well as a data store. As like with any initial placement and load balancing, we will honor all the constraints and rules, be it CPU, memory, or network. All these constraints are satisfied as part of our admission control. So now, I shared the numbers about the rules wherein 89% or even 90% of the clusters have rules. And also talked about like the ability to move the VM from one vCenter to another vCenter. When you move the rules, when you move the VMs, if you have to recreate all these rules, it's going to be a pain in the neck. And if your cluster is bigger, like the way we are saying, the pain will be much lower than the neck. So what we did was we introduced a feature wherein we will be able to like migrate the rules as part of our migration. So how does it work? In this example, I have affinity rule defined between two VMs. And when you move the VMs to another cluster or another vCenter, we automatically create that particular rule at the destination. And when the second VM moves over there, we disintegrate or like we remove the rules at the source and then we will make sure that they are satisfied at the destination. Now both the VMs are co-residing on the same ESX host. The only thing that we support in this particular release is VM to VM affinity rules and VM to VM anti-affinity rules. We don't support VM to host affinity rule. Any guess why we don't support VM to host affinity rule? Exactly. The host is not moving, so we can't carry the rule along with us. If the host were to move along with us, then we would have carried the rule with it. So we don't know which host we have to create the rule with. That's why VM to host affinity rule, migrating that one doesn't make sense. The next feature which I want to get into is the improved overhead memory computation. This is something very internal to the DRS, but having a good knowledge of this one will certainly help as you have like more consolidation ratios, either because you are using a vSAN cluster or you are using your DRS cluster for VDI workload. So quick intro of like static overhead. Static overhead is something that you have to like reserve in the VMX or in the VM kernel for a VM to power on. It's a minimum memory guarantee that you have to have for your VM to power on. If you don't reserve this particular memory, then the VM will not power on. You need at least this much of footprint for your successful power on. So prior to 6.0, we used to have this pre-computed value of the static overhead. Given a VM of certain size, this is the kind of static overhead memory that I might need for the power on. As with any of the DRS features, we are very conservative. We don't want the power on to fail for any reasons. So we used to compute a very, very conservative value, assuming that you would have all the devices, assuming that you would have all the features turned on, and then we used to come up with some value which used to be like really high for the power on purposes. Of course, after you power on the VM, we don't need that particular memory, because once the VM is powered on, there is no need to reserve this memory anymore. We will reduce that one. But for the initial power on purposes, we used to reserve a big chunk of memory for it. So quiz time again. So I've just taken an example of a typical CPU size. I have 8 vCPU and 128 gigabyte. The static overhead that we used to like reserve for the power on of this particular VM used to be around 12 gigs. Any guess what it is right now with our advanced computation?
1 gig.
Absolutely. Man, you are on a roll. It's approximately 1 gig. So we have drastically reduced the amount of memory that we upfront reserve for the power on. As I mentioned, this is not a memory that you are losing it, but at the time of power on, there is a need for us to reserve this for a successful power on a quick power on. So how does it help you, you might ask? In case of like HA failover, as you know, HA is capable of powering on 32 VMs at a time. If suppose you have a host with 16 VMs or 32 VMs running on it, and there are other hosts available, you can parallelly power on all of them. Earlier, that computation used to be like, we had to serialize it, because upfront I don't have that much memory to like power on. But with this capability, now all the parallel power ons can happen simultaneously, thereby your availability will increase significantly. In VDI workload, where there is this boot storm, which is very typical, you will see like much better power on times. So another improvement that we did in vSphere 6.0 is the increased cluster scale. In 5.5, our cluster scale limits are like 32 hosts and 4,000 VMs. In vSphere 6.0, it will be 64 hosts and 8K VMs. And both DRS and HA has been thoroughly tested at this particular scale. And another thing that we did in vSphere 6.0 is the scale numbers are identical either for your Windows VC or for your virtual appliance. If you want to use the VCSA, then the scale numbers and the performance number are identical with the Windows. There are other performance improvements, some nitty-gritty details about the improvements which we did. The overall throughput of the operations has increased by 66%. When I say the operational throughput, it is the power on, the linked clone, the snapshot. All these operations go through DRS, and then we have made significant improvements in that one. As I mentioned, the power on latency has increased by 25%. Clone latency has increased by 18%. And the vMotion operation itself has increased 60%. Because again, when we are moving the VM, we have a better analysis to understand like how fast it can be migrated. Also, we know what kind of reclamation we need to do. So how does it help? It will be like help in like faster maintenance mode. As I said, maintenance mode is one of the most popular features of DRS. Now, when you put a host into maintenance mode, there are like two things you will see. One, a parallel vMotion of all the powered off VMs. The evacuation will be in parallel. And then even since the vMotion itself has improved, you will see that the host goes into maintenance mode much faster. So all these things are captured in this particular white paper. It has the numbers at different scales, different sizes. It's a very detailed white paper that the, VMware has published, and that's the link for that one. So now that we looked into the features that got introduced in vSphere 6.0, let's look into some of the advanced options that are available and that are at your disposal to maintain your clusters. As I mentioned earlier, no two clusters are identical, so there is no one glove which fits all the hands. So in certain scenarios, you might have to like tweak some of the advanced options of DRS. I would hate to say this one, but we have close to like 120 advanced options which you can use to tweak and then make DRS work the way you want it. But I wouldn't recommend tweaking all of them because it becomes like a nightmare to like know which one of it has been tweaked, and then when you have a GSS call, it becomes like literally hard for us to figure out what implication it is having. So in this particular section, I'm going to tell only the ones which are very popular and which we have recommended to a couple of customers. The first and the foremost is the uniform VM distribution. Internally, we popularly refer it to as peanut butter spreading. What this means is if there are like n number of hosts and m number of VMs, we evenly distribute these particular VMs to all the hosts. And some of the admins like to see the VMs being evenly spread out in their cluster. One, because they want the availability to be like really good. If one host fails, then there is like it's a predicted number of time it takes to like restart the VMs. I mean, they like the predictability about it. Just because the VMs are like evenly spread doesn't necessarily mean that the VMs are happy. But if you set this particular setting either at the host level or at the cluster level, then we will ensure that the VMs are like distributed uniformly across across all the hosts in the cluster. The second one is the vCPU to PCPU ratio. This is very popular with the service providers. They want to like ensure that there is a certain vCPU to PCPU ratio that is maintained. As I said, the default value is 8, and if you want to like override that one for whatever reasons, you can override that either at the host level or you can override it at the cluster level. The third advanced option is similar to the vCPU to PCPU, it's vMem to PMem. Some admins are very nervous of overcommitting the memory, and in those particular cases you should be able to like set what should be the vMem to PMem ratio, and then DRS will honor it as part of its initial placement and load balancing. The two options, sub-bullets in that one is at the host level, one is at the one is at the cluster level. If it's a homogeneous cluster where all the hosts are like of uniform sizes, then you can set the cluster level setting. which is the typical deployments which we see. But if your hosts are of different sizes, then you can use the host level setting. This is the active memory and the consumed memory management. We have a couple of customers who want DRS to make decision based on the consumed memory and not based on active memory. Let me repeat that one. DRS, when it makes the initial placement and load balancing calls, it looks at the active pages of the memory, not the consumed memory. So just a quick intro on like what is active and what is consumed memory. Assume this is the configured size of the VM. In the lifetime of the VM, if it has touched the memory, it has utilized it sometime like 30 days back or 50 days back or sometime in its lifetime, that's the consumed memory. Active memory is the one which is currently being used, which is currently in the active pages. So that's the active memory. You can either make DRS work for the active memory or the consumed memory. What DRS does today is, so that the memory between the consumed memory and the active memory, we call it as the idle memory. Whenever DRS makes a decision, what it does is, it takes the active memory into account and then adds a buffer of 25% for the growth of the VM if the demand spikes beyond the active. So that's the buffer that we add. Now, if you want DRS to like do the load balancing and initial placement based on the consumed memory and not on the active memory, all you need to do is change this 25% value to 100%. That's pretty much it. We have like many customers who want to do it because they have sufficient memory provision, they are deep pocketed, they don't care about whether the memory is being active or not. If that memory has been touched once, for example, if you are running a Windows VM, the first thing the Windows VM will do is go and then zero it all of them. So in that particular case, your consumed memory is your configured memory, and they are okay with that one. Make your decision based on the configured memory because I have enough memory provision. So as with any of the advanced options, please make sure that you understand it clearly. If you don't understand when to use it or how to use it, feel free to like involve your GSS, look through some of the blogs that are there around this one, shoot an email, and then we will be able to help you out whether these advanced options are good for your environment or not. So now let's jump into the best practices. We rarely see customers not following the best practices, but once in a while we do see that whenever there is an SR, we look at the logs and then we figure out that the best practice guidelines are not practiced. If you follow the best practice, there are two advantages. One, there won't be any surprises because we would have tested thoroughly with those best practice guidelines. Two, you will avoid some of the pitfalls. There are some caveats that come with some of the settings and then you will avoid them. So first and the foremost, which is like very well known, is the full connectivity for the hosts in the cluster. Even if you have partial connectivity as on the left side of your screen, DRS works. But the only challenge over there is now you have silos within your cluster. Even for your HA failover or even for our load balancing, the number of moves that are available for us will become limited. If you have full connectivity, one, we will have the entire cluster at our disposal to make the decision. Two, whenever there is a host failure, then we have the entire remaining cluster of n-1 available for our failover purposes. So we recommend full connectivity. The second one is the power management settings. Once in a while we hear from customers saying that I have ready time in my environment. Why is DRS not looking into the ready time? And then we get the VM logs, we get the VM support bundle. When we start looking at it, then we realize why there is ready time. Because there are two levels of power management settings in the host. One at the BIOS level and another at the ESX kernel level. So at the BIOS level, make sure it is set to like OS control mode at the minimal. There are like higher performance mode, but at the minimal, make sure that it is at the OS control mode. There were certain versions of HP blades that got shipped whose BIOS setting was lower than OS control mode. There are like only few flavors of those or few versions of those. If you see ready time in your environment, first thing, make sure you check the BIOS setting. The second thing is the ESX Power Management setting. This one, set it to at least balanced. There is like high performance mode and then higher performance mode in that option. But at the minimum, make sure that you have set it at the balanced mode. If you don't do this one, then DRS doesn't have the visibility as to like a reduced CPU cycles under the hoods. So it assumes that that particular CPU cycle is being satisfied, but in reality, the CPU cycles have been like reduced for power saving mode. And as a result, you will see the ready time. The third best practice tip is the aggressive setting. As I said, this influences the minimum goodness and then how aggressive we should be in filtering out our moves. The default setting of 3 works the best. If you set it to like aggressive mode, then any of the cost benefit analysis that we have done, whether the result is -2, -1, 0, 1 or 2, all are good for us. So we will start making the moves. So if it is like very aggressive, then you will see a lot of vMotion in your environment. If you set it to too conservative mode, then what happens is like it has to be the best move. The benefit of the move should like outweigh the cost by a significant magnitude, which is +2. And that's the only move which is considered for the movement. So the default setting of 3 is right in the middle, and then we recommend to like leave it at that one. Then comes the automation level. As I shared the numbers, 80% of the clusters are in fully automated mode. The ones which are not in fully automated mode, there is a reasoning behind them. One, there is some kind of a ticketing system or a change management database integration, either through like VRA or like any other automation tool, where they want the DRS to make the recommendation. They take that recommendation, get the approval, and then allow the recommendations to be applied. Those are the scenarios where you would like to have the DRS in either the manual mode or the semi-automatic mode. Other than that, the fully automated mode always works best because it's constantly learning, it knows from its moves. It doesn't have to like take into account some of the recommendations that are sitting there for a long time, because every 5 minutes, if you don't apply it, then there is an old recommendation sitting, and then we have to take that into account for our future recommendations. Priority inversion. Resource pool is like very powerful construct that is leveraged by many of the service providers, including vCloud Air. One of the things that you need to pay attention over there is the priority inversion. In this particular example, as you can see, the intention of the admin was to have RP1 have a higher priority than RP2. You have specified it as like 200 to 100 or like 2000 to 1000. It's like relative priority. Unfortunately, if you are not careful and then you cram in more number of VMs over there, then you see priority inversion. Why is that so? Because unknowingly you are diluting the number of shares that RP1 has. So what do I mean by diluting is it has like 20 gig. Since you have crammed in 5 VMs over there, all of them will get 4 gigabyte. Now if you put one more VM over there, then there are 6 VMs and they will get roughly like 3.3 gig. If you put one more VM over there, then again you are diluting those shares. So in scenarios like this, our best recommendation is to like set the ratio between the two to be really high so that you have the option of putting more VMs into high priority RPs. We rarely see this CPU affinity being set, but there are some customers who think that by setting the CPU affinity they will get performance benefit. To the contrary to that belief, What CPU affinity means is this particular VM cannot use any other CPU but the CPU which it is assigned to. If you have a VM which is hosting latency sensitive applications, then I highly recommend to set the latency sensitive setting on that VM to either low, medium or high. Once that setting is done, the ESX scheduler will give higher preference to this particular VM. Also, DRS, when it is making load balancing call, will ensure that this VM is not moved around or other VMs are not moved onto that particular host. So if you have a latency sensitive application, then make sure to set this particular setting. So now I'll jump, I have 10 minutes, so I'll go through some of the future directions. Given the popularity of the DRS and then how much we get a lot of feedback on DRS, the VMware management spends a lot of energy and cycles into the R&D of DRS. So I will touch upon some of the things that we are working on, which will be included in the future releases. The first and the foremost one, we are calling it as the proactive HA. As you know, all the HA solution that exists today, including yours truly vSphere HA, are all reactive in nature. We wait for the ESX host to either PSOD or like die, then we restart the VMs. The challenge with that one is there is a downtime associated with it, meaning that the VM has to be restarted, and even if the VMs are restarted quickly, they would have lost the cache that they have built. So what we are doing is, after looking at all the data that we have collected so far and partnering with our vendors, we realize that there are telltale signs when a ESX host is going to fail. Either there will be a memory failure, ECC failures, or there will be power failures, or there will be some storage failures. And our vendors, either be it HP, Dell, or any of the other server vendors, they have the analytics to know when that particular ESX host is going to fail. And we are integrating with them. Their solution will be a plugin into our web client, and they will inform the DRS as to like whether that particular host is going into a partially degraded mode or a fully degraded mode, severely degraded mode. And DRS will incorporate this input as part of its load balancing. If it is partially degraded, then we are introducing a new state for the ESX host called as the quarantine mode. What quarantine mode means is we will opportunistically try to evacuate as many number of VMs as possible from that particular host. If it is severely degraded, then we put the host into maintenance mode. That means that we move all the VMs as if that particular ESX host is going to be on fire very soon. So those are the two modes which we are introducing. And given that it's a 1.0 release, we want to take baby steps. We want to give full control to the VI admins. They can tell us which event we should react to, which one you have to filter it out, what kind of actions we should be taking. And as with the DRS, there is a manual mode, there is a semi-automatic mode, the fully automatic mode. You can set that one. If you are very cautious about this particular feature, you can also just set no action for each of them, just raise an alarm for me, and then we will just raise an alarm for you. So we give full control to the VI admin. The next one is the close integration with the NSX. With NSX becoming more and more popular in like big environments, we will have a tighter integration with the NSX. We will be able to get all the information from the NSX. As I mentioned earlier, the network traffic is very dynamic in nature. But NSX, who is in the flow, they exactly know which two VMs are talking, which is the elephant flow, which is the mice flow. And then we will take that information to do our load balancing. We will never mix an elephant flow with a mice flow because the elephant flow will trample upon the mice flow. And we will put two chatty VMs together on the same host to minimize the cross host communications. Proactive DRS. This is something which we already put out as a fling, and many of the customers have downloaded it and then have given very valuable feedback for us. This is a tight integration between VROps and DRS. VROps has this analytics engine which helps you to like predict the workload into the future, 5 minutes, 30 minutes, 1 hour, 2 hour. So you can specify like to what extent you want to like project the memory growth or the CPU growth. So we will take that information into account in the DRS, and then we will do the moves proactively rather than reactively. Again, one thing I want to emphasize over here is, since it is a predicted information, however good our prediction is, there could be a false positive. Because of that, we will never make a move to satisfy a future demand by clipping the current demand. We will never starve a VM or make a VM unhappy to make it happier in the future. So we will always ensure that minimum guarantee is there. So if all things being equal, all the VMs are happy even after I move, plus he will be happier 5 minutes or 30 minutes from then only we make the moves. This also tool, we already put it as a Flink, and it has been like extensively used by many of the customers. It's a WhatIf Analysis tool. It will be a tab in your web client where you can point your browser to like a existing DRS cluster, and then you can tell, if 2 hosts fail over here, can you tell me how many of my VMs won't be able to restart in terms of like availability? Or you can say, if I add 2 more hosts into this particular cluster, how will my load distribution look like? Or you can also say, like, if I take out 2 hosts for maintenance mode purposes, can you tell me how the load distribution looks like? It's an what-if analysis. It's exactly the same algorithm that DRS uses internally for our what-if analysis purposes. We are just putting a UI in front of that one. In the back end, the work is exactly the same that DRS does today. It's just like a UI tab that we are adding. AutoScale of the VMs. This particular thing is something which we had been working for like a couple of years, where we were dabbling with our artificial intelligence, machine learning, and then the heuristics-based decision making. This is to like take the automation to the next level, wherein we should be able to like right size the VM based on the performance metric you have specified. Initially, we will be introducing this as a service in vCloud Air because it's like much more faster for us to like iterate over there. So we will be doing we are already doing a beta in this year, and the early part of next year we will be doing a general availability of this one. In this particular case, given the end-to-end latency of a application, we will ensure whether we need to add more VMs or we need to like hot add or hot remove the CPU. Hybrid DRS. You might have heard in the keynote address, our main goal is to make sure that there is a seamless extension between your on-prem data center and vCloud Air. And DRS is like well positioned to take advantage of this one. With this particular feature, what we are trying to do is, based on the policies that you have specified, either we will do the placement on your local data center or we will place it in vCloud Air. We are already using this in our internal cloud, in our dev test cloud in VMware, where we are dog fooding it. What we do is like we set our utilization at 80% on the private cloud. So whenever the utilization is above 80% for our dev test workload, we burst it into our vCloud Air, where it is a pay-go model. And then the test runs over there and the results come back. Our developers don't know whether that particular workload ran in the private data center or in our public cloud. All they care about is the test runs and they get the results back. And the check-in is done into the repository. So you can specify any kinds of policies over there. We have set like 2 kinds of policies. One is a threshold. Another is like what kind of workload can go and what kind of workload cannot go. So hybrid DRS will be able to take care of that one. Once the cross-cloud vMotion starts working, which is working, but once it is tested at scale, then we will be able to like even move back the workload once it has been provisioned to the public cloud. So with that, Please fill out this survey if you get a chance, and thank you very much for attending the sessions.